As you know, proving trigonometric identities could be challenging. So today we want to talk about a straightforward but powerful method for doing this. Given a right triangle, we consider this angle theta, denote the adjacent side as x, opposite side y, hypotenuse r. The three primary trigonometric ratios are sin theta equals opposite y over hypotenuse r, cosine theta equals adjacent x over hypotenuse r, tan theta equals opposite y over adjacent x. The reciprocal of sin is cosecant, so this one equals 1 over cosecant theta. The reciprocal of cosine is secant, so this one equals 1 over secant theta. The reciprocal of tan is cotan, so this one equals 1 over cotan theta. Using Pythagorean theorem, we know x squared plus y squared equals r squared. So x squared plus y squared equals r squared. When the measure of the angle is less than 0 degree or greater than 90 degree, we can use the reference triangle for data. So all these formulas are still valid. Now let's see how to use these basic formulas to prove some challenging trigonometric identities. Let's look at the first example. Bracket cosecant theta minus cotan theta squared. The right side equals 1 minus cosine theta over 1 plus cosine theta. Let's start from the left side. Cosecant theta equals hypotenuse r over opposite side y. So we get r over y. Cotan equals adjacent x over opposite y. X over y squared. Now we combine these two fractions. So we get y squared at the top, r minus x squared. Using this formula, we can change y squared to r squared minus x squared. So the bottom is r squared minus x squared. The top still r minus x squared. Now we factor the bottom part. Get r minus x, r plus x. The top still r minus x squared. Then we cancel one common factor, r minus x. So we get r plus x. The top is r minus x. Now we divide r for top and bottom. So we get r divided by r 1, x divided by r. The bottom 1 plus x over r. You see x over r is actually cosine theta. So we get 1 minus cosine theta. The bottom 1 plus cosine theta. There is the right side. So we're done. Now let's look at the other example. Sin squared theta times tan theta plus cosine squared theta times cotan theta plus 2 sin theta cosine theta. The right side, tan theta plus cotan data. Let's start from the left side. Left side equals sine data equals opposite y over hypotenuse r. So we get y over r squared tan opposite y over adjacent x cosine equals adjacent x over hypotenuse r. So square cotan adjacent over opposite y sine again y over r cosine x over r. For the first term, y squared times y equals y cubed. The bottom r squared x. The second term, x squared times x, so x cubed. The bottom r squared times y. The last term, 2xy. The bottom r squared. You see, r squared times x times y is common denominator, so we put them together. R squared x y. For the first denominator, we times y to get the common denominator. So the top also times y. We get y to the 4th. The second term times x, so the top times x, we get x to the 4th. The last term times xy, so we get 2x squared y squared. Now, x4 can be written as x squared squared plus 2x squared y squared. Y to the 4th equals y squared and then square. The bottom still r squared times x times y. You see the top x-ray is a perfect square. The inside part should be x squared plus y squared. The bottom still r squared x y. Now x squared plus y squared equals r squared. So we get r squared and then square. The bottom r squared times x times y. So the top becomes r to the 4th. Bottom r squared x y. Now we cancel r squared for top and bottom, so we get r squared over x y. Now we change r squared to x squared plus y squared using this formula. So we get x squared plus y squared over x y. Then we break up the fraction to two fractions. So we get x squared over xy plus the second y squared over xy. The first one can be simplified as x over y. The second, y over x. So we see x over y is cotan theta. Y over x, tan theta. It is the right side. So we're done.